So we want to find the volume of just this shaded part. And we notice that this shaded part is a trapezoidal prism. It's got a trapezoid at the front and a trapezoid in the back, and they're connected. So we pull out our volume of a prism formula, and we know it's just the area of the base, so the area of that trapezoid times the height of the prism. Now you might have like fancy formulas memorized for areas of trapezoids with like base 1 plus base 2 times the height divided by 2, but the height is a little bit hard to find there, right? You'd have to draw the height perpendicular to the base, and that you could find it, but we don't want to, because instead we're just going to use, hey, I know that that trapezoid is this, that area is this big triangle minus this little triangle. And I'm just going to find the area of the big triangle, the area of the little triangle, subtract them to get the shaded area that's left. So they do that over here. The area of this big triangle, it's nice, the base and the height are perpendicular. So it's 6 plus 6 is 12, 8 plus 8 is 16. So I have half of 12 times 16. That gives me 96. And then I go for the little triangle. Here we go. So the base is 6 and the height is 8. So 1/2 6 times 8 is 24. And so the trapezoid, you just take away this from the big guy to get the shaded guy. So just subtract those, you get 72. For the volume, it's going to be that area of the base, that's 72, times the height of the prism. And the height of the prism is always that length that connects the two bases, so there's the trapezoid in the back that we can't see. So we're looking for that length there, which is 2 meters, which is the same thing as 200 centimeters. So thank goodness they didn't try to trick us up and have one without a couple extra zeros there, but that's where those 2 extra zeros are coming from. 2 meters is the same thing as 200 centimeters. So area of the base times the height gives you that for your volume, and it's there, it's A, we're done. Check.